Good morning, mathematicians. This is a Pondering Math video by me, Ann Faderwish, of Lesson Fundamentals. Today we're going to consider why the flip with inequalities. This is the episode where we ponder, why do we reverse the inequality symbol when we multiply or divide by a negative number? And this presentation is geared towards teachers and how to teach this concept. I generally start with a notice and wonder. And notice and wonder is a low floor, high ceiling math routine that really allows an entry point for all learners into the lesson and helps activate prior knowledge. So I usually say, jot down at least one thing you notice about what's presented, and jot down at least one thing you wonder about what is presented. I give students a minute or so to ponder and jot those ideas down. Early finishers, I say, think of another thing that you notice or another thing that you wonder, so that everybody should be working for the entire time. So here is what I present to begin with. I say, what do you notice? What do you wonder? I give the moment for them to ponder, and then I begin a class discussion. What do you notice? What do you wonder? And I begin writing down what they notice and what they wonder. Without any judgment or comments, I just write what they say. Some of the typical things students would notice: it's a number line. There are positive numbers, negative numbers, and zero. The marks are evenly spaced. The numbers increase by one going left to right, and they decrease by one going right to left. Some of the things they wonder about: why are there arrows on the end? Why does it only go from negative 10 to 10? Why are you showing a numbered line? And if you work with middle school students like I usually do, they often wonder, why are we doing this? Why do I need to write something down? If they didn't already comment on it, help them notice that if a number is to the left of another number, it is less than that number. If it's to the right of the other number, it's greater than that number. So as we go from left to right, the numbers are getting bigger. And a number to the left, like negative 10, is less than negative 9. We're going to zoom in here on part of our number line. And I would really focus on 2 and 3 here. And I'd ask them, which is greater, 2 or 3? And very quickly they'll say, well, 3 is greater than 2. And I might turn it around and say, which is less, 2 or 3? I'd say, well, 2 is less than 3. And then I'd show them the notation. 2 is less than 3. And then we'd look on the other side of 0. And we'd look at negative 2 and negative 3. And I ask them, which is greater, negative 2 or negative 3? And this sometimes takes a little bit longer, but we talk about the fact that negative 2 is to the right of negative 3 on the number line. Negative 3 is to the left of negative 2 on the number line, which means that negative 2 is greater than negative 3. And I might even move these over. And at this point, it's usually an aha moment. Oh, 2 is less than 3, but negative 2 is greater than negative 3. And then I'll take it a step further and multiply each side here by -1. So of course I get -2 on that side, and I get -3 on this side, but I can't just bring the inequality symbol down. To keep it a true statement, I have to reverse the inequality symbol. Here's another way to think about it. Let's consider -2x is greater than 4. What do you notice about what the value of x has to be in this? I would give them a little bit of time to consider it, but generally they'll come up with the fact that x has to be a negative number for -2 times x to be greater than the positive number 4. So I'll start out just by solving the equality. -2x equals 4. They would know if we divide both sides by -2, we'll get that x equals -2. So this is our boundary point. This is where we go from x giving us an equality and x giving us a number greater than 4 or less than 4. So let's substitute in and see what happens. So of course, when I substitute -2 in for x, I've got -2 times -2, which is 4, and 4 equals 4. When I substitute in -1 for x, I've got -2 times -1, which is 2. And 2, of course, is less than 4. When I substitute 0 in for x, I've got 0, which of course is also less than 4. If I substitute -3 in for x, I've got -2 times -3, which is 6. And 6, of course, is greater than 4. When I substitute -4 in for x, I get -2 times -4, which is 8, which also is greater than 4. So if we look at our values, the only values that are going to work in this, the only values that work in this chart are -3 and -4. But of course, any value that isn't an integer that is less than -2 is going to work. So we're going to put an open circle here at -2 to show it's our boundary point, meaning -2 isn't part of the solution. And then we're going to go in the direction of those values that worked. So it's very clear to see here on our graph that x is less than -2. And this is where I point out that this was greater than here, but our solution x is less than. Let's consider it another way, strictly algebraically. I'm starting with the same inequality. -2x is greater than 4. I'm going to start by adding 2x to both sides. Leaves me with 0 is greater than 4 plus 2x. Going to subtract 4 from both sides. I've got negative 4 is greater than 2x. And now I'm going to divide both sides by 2 so that I'm isolating my x on the right side. And I'm left with negative 2 is greater than x, which means that x is less than negative 2. You can see we started with the inequality symbol as greater than, and our solution wound up with it less than. So that's 3 different ways to think about why, when multiplying or dividing both sides of an inequality by a negative number, we have to reverse the inequality symbol. And as you can see down at the bottom here, when we divide both sides by a negative 2, we have to reverse the inequality symbol to keep it as a true statement. Hopefully this gave you some ideas of teaching students about why we reverse the inequality symbol or why we flip the inequality symbol when we multiply or divide by a negative number. Please check out my teaching resources for lesson fundamentals at www.teacherspayteachers.com/store/lesson-fundamentals.